Hi everyone, and welcome to the InSight Atmospheres Quiz Answers. My name is Claire Newman, and I am an atmospheric scientist on the InSight team. So on Mars, we've just gone past autumn equinox in the Northern Hemisphere, which is where InSight sits, just north of the equator. This figure from the quiz shows the hourly average pressure, air temperature, and wind measured by InSight a few Mars days or sols ago. As you can see, every sol there's a big change in air temperature and surface pressure, much more than we experience on Earth. One big reason for this is that Mars has a much thinner atmosphere than Earth, which means it doesn't hold on to a lot of heat overnight. So there are very big differences in the surface and near-surface air temperature measured by InSight during the day and at night, about 80 degrees Celsius right now. Surface pressure is caused by the mass of air over us. So when the atmosphere warms over the daylit part of a planet and cools during the night, that causes the daytime region to expand, which pushes masses of air from one part of the planet to another and changes the surface pressure. So the big variations in temperature in Mars's atmosphere also lead to big changes in pressure. And you can see that the surface pressure by InSight is much lower in the afternoon than it is in the morning. Mars is also a very active place when it comes to winds. As you can see, right now, the average hourly wind measured by InSight varies from about a meter per second to 9 or 10 meters per second in every sol. The weakest winds are at the end of the afternoon at about 6 p.m., and the strongest winds are in the late morning. To give you some idea of what that means, winds of about 9 meters per second work out to just over 20 miles per hour. But that's just the wind speeds averaged over an hour. If you follow the link to our InSight weather website and look at the table that's on there, you can see that InSight regularly records maximum daily wind speeds that are twice as strong as the maximum in the hourly average, up to 20 meters per second or 44 miles per hour. How does that compare to winds on Earth? Well, by comparison, the peak wind speed ever measured on the Earth's surface was over 250 miles per hour. But that isn't to say that InSight isn't going to measure stronger winds and hasn't measured stronger winds at other times of the year. And we'll come on to that a little bit later. So let's look at the answers to the quiz. The maximum hourly average wind speed, which is what was shown in the above figure, is around 10 meters per second at the present time. And the winds are rather weak at the end of the afternoon, around 6 p.m. And the temperature difference during the day is around 80 degrees Celsius. But the atmospheric pressure is not highest in the middle of the day. So that is a statement that is not correct. And as for where the winds on Earth are most like the winds on Mars, well, that's complicated. The answer is that it depends on exactly where and when you look, because wind patterns can change pretty quickly. If you click on the link that takes you to the Meteor website and scroll down to the animation at the bottom, you can explore the world's wind patterns at different dates and times of day. If you change the time and date to Sunday, April the 5th at 1 p.m., you'll see that the wind over Iceland was very strong. But if you change it to Thursday, April the 9th at the same time of day, the wind speed is almost down to nothing. And you can also see a lot more differences if you look at different times of day as well. Winds also change an awful lot with time and location on Mars, though. In fact, since InSight landed in November 2018, the strongest wind speed we've measured was over 30 meters per second, which comes to almost 70 miles an hour. This coincided with changes we could see on the Martian surface. So this shows the difference between two images, one of which was taken before and one after that big wind peak. And it shows that a track-like feature appeared on the surface between them, which was probably due to something scrubbing off or lifting up small dust and sand particles off the surface to make it a little bit darker. So this wind peak was also accompanied by a big pressure drop, and that's a sign that a big convective vortex passed nearby at the same time. So maybe it was something like these ones that were seen by the Spirit rover in Gusev crater. These are referred to as dust devils because you can see that the vortex has picked up enough dust and sand that you can actually see it visibly in images. The thing is that we haven't actually detected any dust devils in InSight images as yet, although we've measured some huge pressure drops. So it's really interesting why we haven't actually imaged any dust devils yet, and maybe it's because we don't have enough dust on the surface to lift up to make them visible. But that's a story for another time. Now, the final thing to say is that even if those kinds of winds were blowing you around on Mars, they really wouldn't have much effect. And that's because Mars has air density that's about 100 times less than on Earth. So you really wouldn't feel the force of that wind as much as you would if the same wind speed were blowing on Earth. But those kinds of speeds are enough to move sand and dust around. And that's the main reason that Mars regularly has huge global dust storms that cover the entire planet up in the atmosphere. And also lots of gorgeous dunes and other alien features all over its surface. It's also the reason why InSight's sensitive seismometers are covered by a wind and thermal shield. And that's so that they can reduce the noise from wind and make sure that they can measure as many marsquakes as possible. We hope you enjoyed this week's quizzes and learned a lot about Mars and InSight. Come back next week for more.